Good morning. Is everyone awake? Kind of sober? Well, thanks for coming to this session, More Things in Active Directory That Can Affect Your Desktop and Application Virtualization Efforts and How to Fix Them. The slide title is almost as long as the entire session. So please tweet about this session. That way my wife knows I'm actually in Copenhagen behaving myself, and my mom can actually think her son is being a productive member of society. Is there anyone in here who doesn't know me now? Okay, well, then you know who I am. I'm Webster, out of Nashville, Tennessee, CTP, run the website carlwebster.com, accidental Citrix admin, and I'm all over the internet at all these places. Now, before we continue, just want to let you know, so you're not scrambling trying to take notes, screenshots of all the slides and everything. At the end of the presentation, provided I've got my time zone calculations correct, there will be a PDF of this presentation, all the slides, all the notes, comments from the directory services MVPs and experts who reviewed this presentation for its accuracy and content. All that will be available. And then also at the end, there's also a reference slide that I don't show, but it's in the PDF, and there's about 90 some odd references in the on that slide in the PDF. Now, how many heard my presentation or saw the video or read it from last year, the 10 things in AD? Yeah, a couple of you? All right. Well, here are the things we covered last year. That we're going to check our domain enforced functional levels, and we're going to make sure all domain controllers are global catalog servers, and we're going to have no manually created connection objects in sites and services. And we're going to check the netlogon.log file for missing subnets. And we're going to create reverse DNS lookup zones for all subnets that we create in sites and services. And then we're going to clean up DNS of unnecessary duplicate host names and IP addresses. And then we're going to clean up orphaned domain controllers, make sure the PDC emulator is configured properly to be the authoritative time service, and make sure all domain controllers have their DNS IP settings configured properly. And we're going to use Microsoft's and other vendors' Active Directory design guidelines. Now, from last year's sessions, I kept getting the same questions over and over. So the top two questions from the previous sessions are, hey, last year you covered a single domain, single site configuration. Well, what do we do if we have a single domain with multiple sites? Or what if we have multiple domains with multiple sites? What are some recommendations for how we should configure all the domain controller IP configuration settings? And by far, the most frequently asked question, hey, you covered all that removing duplicate DNS records and all that aging and scavenging stuff. So I went right back to my office. I configured DNS aging and scavenging. I came back the next day and nothing happened. So why was nothing cleaned up? And then some of them, the more adventurous ones, will say, hey, I found this command on the internet I could run to help with aging and scavenging. I ran that on Friday, and I started getting calls over the weekends because all my servers were deleted from DNS. What happened? Needless to say, that's not a very good thing to have happen. So we're going to start off with the most frequently asked question. So the agenda for that is we're going to cover the basics of aging and scavenging, because there's a lot of stuff that goes into actually making sure aging and scavenging is configured properly. Now, aging and scavenging, are y'all familiar with the term euphemism? It's a word that you use in place of another word. Well, scavenging means deleting. But if Microsoft had called this aging and deleting, people would have freaked out. So they use a euphemism. Instead of saying deleting, they just use the word scavenging. So when we talk about aging and scavenging, we're talking about aging DNS records and then deleting stale DNS records. But Microsoft will never use the term deleting. And then when can scavenging or deleting start? And then aging and scavenging for a sample record. Then by the time we get to here, it may be time for just a short break, so when that session ends, people can come over here, or if you're already going over to the Netscaler, that way we've got a little break so we can change sessions, and we may get to there, and then we'll put all the aging and scavenging and DHCP stuff together. Now, when I start going through this stuff, if you wouldn't mind, just wait until we get all the way to the question section before you start asking questions, because I'm just going to cover each topic one at a time, and each one builds on another. So a question you may have may be answered within another slide or two. So we're going to start off with the current server time. I don't know, you're probably thinking, Webster, come on. Current server time? Well, last year we covered that time is very important, very critical in Active Directory. And it's also very important for your DNS server. And it's also important that your DNS servers are in the right time zone. Because in the United States, people will buy servers from Dell, which is in the central time zone, and they'll ship them off to New York City, which is in the eastern time zone, or over to someplace in California, which is in the Pacific time zone, and then people never bother to change the time zones, and then they wonder why stuff is off by hours in Active Directory. I don't know if that's a problem over here in Europe or not, but it is a big problem in the United States. So accurate time on your DNS server is very important. The next thing, resource record timestamp. Now you'll see that you will get a timestamp. Now you'll see the time, it says 10 a.m. If this record were created at 10:59:59, the timestamp will say 10 a.m. It always rounds down to the hour. And then another thing, by default, resource record timestamps are not replicated. Why? Because by default, aging and scavenging is not enabled. And Active Directory is smart enough to know that if you're not using aging and scavenging, there's no reason to waste replication bandwidth with replicating resource record timestamps, because they're useless. The only time the resource record timestamp comes into play is when you have properly configured aging and scavenging. Now by default, you cannot see the timestamps for the resource records. And that freaks out people, because they'll say, something's wrong, we've screwed something up in Active Directory because we can't see them. No problem. All you got to do is in the DNS console, just enable on View and then Advanced. And then you'll be able to see your resource record timestamps. But what about static IPs and static DNS records? So here's a computer with a static IP, which would be any type of workstation that you would configure with a static IP, or obviously most of your servers like XenApp server, desktop delivery controllers, web servers and stuff like that, you would assign those with a static IP. Well, those are dynamically registered in DNS, and they will have a resource record timestamp. They will also have the checkbox checked, delete this record when it becomes stale. And then, just as a matter of reference, the time to live, the TTL, for a static IP address is 20 minutes. And then a computer with a static DNS record. That's where you go into the DNS console, you right-click the zone, and you say, create a record. Well, you've got the host name, you got the IP address, but it has no resource record timestamp. The reason for that is you have manually created this DNS record, and you do not want it deleted. You do not want it aged. You don't want anything to happen to this. It should always be in DNS. And then you'll notice that the default TTL is 1 hour. Now what about domain controller? Most, I would say all domain controllers should have a static IP address. So we know this is a static IP address because look at our TTL. It's 20 minutes. That means this record has a static IP address that was dynamically registered in DNS, but you'll see it has no resource record timestamp. And the box to delete this record when it becomes stale is not checked. Why? I don't think you want your domain controller DNS records aged or deleted from DNS. That would be a bad thing to have happen. And we'll cover a little bit more about domain controller DNS records shortly. Now, the one thing that people do that can really screw up things is if they go and they turn on, they think they've got aging and scavenging turned on, and then they come back to work the next day thinking that aging and scavenging should be an overnight process. They can't figure out what happened, so it's Friday afternoon, so they find this command on the internet somewhere in Google or Bing, and they go and run this DNS command, age all records. Just think of this as saying, I want you to age and then delete every record in DNS, which is essentially what will happen, because very few places have pristine Active Directories with absolutely no issues whatsoever. If everything is working perfectly, if you run this command, then you'll be fine within 24 hours. But most places are not perfect, which is why they call me, and I make lots of money. So now, let's take a look at our computer with a static DNS record. Remember, by default, the static DNS record, because we can tell it's static because the TTL is 1 hour. After running that age all records, it now has a timestamp, and it is now set, hey, delete this record. And that's not a good thing to have happen. Now, for domain controllers, in my little lab, I had 5 2012 domain controllers. A domain controller, because it's so special, even if you run that age all records, it will get set like this, but then it will immediately, within just a few minutes or a few seconds, it will say, I'm not supposed to have this set, and will undo it. And in my little lab, it happened so fast, I could never get a screenshot, even with 5 domain controllers. It just, you'd run age all records, and even though I had everything set, you right click and look at it, boom, it's already been reset. So I could never get a screenshot. But if you run this, it will flag all domain controllers with the timestamp and with this checkbox. But the net logon service should say, oops, something is wrong in DNS with this domain controller, and it will go out there and reset it. So now, that's all the basics for just the DNS side of it. Now let's go and look at all the aging and scavenging stuff. We're going to start off with the no refresh interval. What this is this is the time period where DNS says, I'm not going to accept any refreshes for a DNS record. I will accept updates, and we'll cover the difference in just a little bit. I will accept no refreshes, which is a good thing, because by default, if you have all the defaults for DNS and DHCP, aging and scavenging in your environment, by default, every 60 minutes, every domain controller refreshes its DNS record. By default, every computer that's Windows 2000 and later, every 24 hours will refresh their DNS record. If you're in an environment that has tens of thousands or hundreds of thousands of computers, can you imagine how many updates to the Active Directory database that would cause? Can you imagine the replication traffic from that? So to help minimize writes to the Active Directory database and replication traffic, DNS says, hey, for 7 days, I'm not going to accept anything except an update. The next is the refresh interval. The refresh interval says, hey, during this 7 days, I will accept refreshes for this record and updates. So it's going to say, hey, I've waited 7 days. I'm not going to accept anything except an update. Now we start the next 7-day period, which is I will accept refreshes and updates. The next thing, the start scavenging time. And you'll also see that it does the same thing. When it calculates it, even if it calculates it to 10:59:59, it rounds down to the hour. And then the scavenging period, which is also by default 7 days. And the scavenging period is just the amount of time it says, okay, if there have been no refreshes or updates during the no refresh period, and there have been no refreshes or updates during the refresh interval, then during this period of time, when I run the scavenging process, if I look at the current date and time on the server, and the resource record timestamp is less than that, then I'm going to go out there and scavenge the record. So now, record refreshes. Refreshes generally occur for the following reasons. When the computer starts, if the current name and IP is equal to the previous name and IP, which is a normal process, that is a refresh, and in the no refresh interval, we will not accept those, or DNS will not accept those. And then a periodic refresh is sent by the computer while it's running, which is, if you're running prior to Vista, that was handled by the DHCP client service, or prior to Server 2008. From Vista or Server 2008 on, that's actually handled by the DNS client service. And for domain, and that's handled every 24 hours. That process will run so it can dynamically refresh the DNS. And then other network services can make refresh attempts. The cluster service will attempt to update all the DNS information for all the nodes in the cluster. And then also for domain controllers, the net logon service will run an attempt to update every 60 minutes the domain controller. So now record updates. Updates can occur for the following reason. When a new computer is added to the network, an update request is sent to DNS to actually create a DNS record. And when we start a computer, if the current computer name and IP address does not equal the previous name and IP address, that's an update. And this will cause, even in the no refresh time period, this will cause the time to go all the way back to day number 1. And then it says, okay, we've had an update, we're going to go back to day number 1, we're going to start all over again with the no refresh interval. And then when the net logon service registers a new domain controller, when a new domain controller is brought online, and after all the group policies have been copied over and that last gpt.ini file has been created, and the sysvol share and net logon shares have actually been created, it's officially a domain controller. Net logon service will now run and create all the necessary DNS records, all the SRV records, that I'm a domain controller and here's my port. I handle LDAP, here's my port. I handle Kerberos and here's my port. I'm a global catalog server, here's my port, and so on and so forth, depending upon all the services that you have running in your environment. Scavenging servers. This is an optional but highly recommended setting that you want. By default, every DNS server in your environment where you go and configure aging and scavenging, all of them will do the scavenging. And that's really not a good thing, because most people have a lot of DNS servers. So Microsoft recommends that you have 1, maybe 2 if you're in a very large environment, but preferably just 1 scavenging server. The reason for that? If something goes wrong in scavenging, would you rather look in the event logs on 1 DNS server? Or would you rather look in the event logs on every DNS server in your environment trying to track down what went wrong with scavenging? I would rather look at 1. All right, so when can scavenging start? Well, we got all these things, and yeah, you don't have to read all that. You'll be able to read all that in the PDF. Now, these are actually, you can look at these things in two ways. And so I'll give you both wordings on all of these. Dynamic updates are enabled for the zone. Wording number one, you can have everything else configured properly, but if you don't have the zone configured for dynamic updates, the start scavenging time will never be set. Wording number two, you can have everything else configured, and then once you set dynamic updates, then the start scavenging time will be calculated and set. Enable automatic scavenging to stale records checkbox is applied on the scavenging server. So wording number one, you can have everything else configured properly, but if this checkbox is not checked, start scavenging time is never set. Wording number two, you can have everything else set, and as soon as you set this checkbox, then the start scavenging time will be set. The DNS server loads a primary zone that is enabled to use scavenging. Not everyone uses Active Directory Integrated DNS. Mark Manasseh in his classes tells people he doesn't use Active Directory Integrated DNS. And a lot of sites I go to, they don't. Because a lot of these people have come from Unix DNS, and they have migrated over to Microsoft DNS, and they still use primary zones. Now, a primary zone is loaded from a file. In some environments, that file can contain many tens of thousands or hundreds of thousands of records. So the file can be very large. And because by default, aging and scavenging is not set, that file can probably be half, 2/3, 90% stale records that are no longer valid. And so in one place I went to, they had well over 250,000 DNS records in their primary zone on a 1 CPU, 1 gig of RAM, RAID 5, 3-drive domain controller, 32-bit. 6 hours it took to load their primary zone file. So every time they rebooted the server, DNS was literally unavailable for 6 hours because it took so long. So, wording number one, until that zone file actually loads, aging and the start scavenging time will not be set. And as soon as that zone file loads and is validated, then the start scavenging time will be set. When a zone resumes service after having been paused, I've never comprehended this, but a lot of people are in the habit of pausing their zones. I don't know why. But if you pause the zone, even though you can have all the other things set, the start scavenging time will not be set. Once you get everything else set, and then you start the zone, and it validates everything, then the start scavenging time will be set. Now, if the zone is AD integrated, replication for the zone must happen at least once. By default, aging and scavenging is not enabled, which means by default, the resource record timestamps are not replicated. So it is highly possible that computer 1, computer 2 could have been registered on multiple DNS servers over a period of months or years. And then when you then go through and enable aging and scavenging, we now have to do conflict resolution. What if I've got 10 DNS servers and computer 1 has actually been registered on all 10 DNS servers? Which DNS record do I keep? Well, I want to keep the one with the most up-to-date or the most current resource record timestamp, which is why it's important to have accurate time in your environment and why it's important to have your servers in the correct time zone. Because if I've got a server that's off by 3 or 4 hours and it gets registered but then also over here, it's also registered maybe an hour earlier. Which one is going to be the most current? Well, this one here, that's in the correct time zone, is going to be 2 or 3 hours more current than this one that's in the wrong time zone. Even though this one is the most current and the most accurate, it has the wrong time on it. So it will be discarded. So having time in your environment accurate is very important. So now once we get all the replication stuff happening, all those records will then come to your DNS servers, and then they will look, oh, I've got 10 records for computer 1, which is the most current. It will then throw away or ignore the other 9. They're still in DNS because they haven't been scavenged yet, but which is the one I'm going to use to base my scavenging on is the most current one. So now once all the previous events occur, the DNS server sets the value of the start scavenging time by calculating the following sum. The current DNS server time plus the refresh interval equals the start scavenging time. And therefore it then goes and calculates our start scavenging time going down to the hour. Now there are a couple other items not listed in any Microsoft documents that will also affect the start scavenging time, which I found about doing my little lab thing for this, and then also looking in some Microsoft support forums, and then reviewing all the articles, TechNet stuff for all the stuff on aging and scavenging. It turns out that a lot of people are in the habit of doing weekly reboots of domain controllers in DNS servers. Remember how the time is calculated, the current server time plus the refresh interval. If you're in the habit of rebooting the server, when it comes up and it starts the DNS service, it says, what's my current server time, what's the refresh interval? That's now the start scavenging time. So the next week, you reboot the server before scavenging has started, and it says, oh, okay, well, today's date plus 7 days is now when I'm going to run scavenging. But the next week, you reboot the server again. In other words, scavenging will never take place. And if you restart the DNS server service, now this is the one that really puzzled me. I can see, weekly reboots, kinda. Especially for those of us in the XenApp world or terminal server world where you got bad applications, you got memory leaks, and so you get in the habit of doing reboots on servers. Really have never understood it for domain controllers and DNS servers. But there are people, in order to refresh the memory on the DNS server, do scheduled nightly restarts of the DNS server service in order to free up the memory, all the stale entries and everything in DNS. Whenever you do that, you reset the start scavenging time to the current server time plus 7 days. The next night, you restart the DNS service. Current server time plus 7 days. And then you keep doing that night after night after night, and therefore scavenging never runs. So these two things can really wreak havoc on your scavenging process. So now let's go and look at aging and scavenging for a sample record. Now, mainly because I have no life, what I did is I created a lab that had 5 2012 domain controllers, and one of them I ran DHCP on, and then I created to kind of replicate what I see a lot when people are messing around with View and Zen Desktop, trying to get the the master image and everything correct, where they'll create a master image and then they'll boot up a VM and something doesn't go right, but yet it's most of the way through the process. It's already got a computer account in Active Directory now. It's got a DNS record. It didn't work right, so they just do a forced shutdown of the VM. Then they go and they fix something, so they delete the VM, and now they create another one, and this one is now Win 7.1. And they boot that one up, and something's still not right. And so they just do a forced shutdown and fix some other things, and then they keep doing that until they get it right, and they're on Win 7.25. And then all of a sudden, they've got all of these stale records out in DNS. So what I did is I actually created a Win7 VM, brought it up, let it get all the way up to the desktop, and then I just did a force shutdown so that it could not clean itself up out of DHCP or DNS. So on day one, I went out there, created it, and then just abandoned the record. So what's the first time interval for aging and scavenging? We have our 7-day no refresh period. So regardless of whether this VM was powered on or powered off, DNS is not going to accept anything other than an update during these 7 days. If I'm all the way on day 7 and I powered on that VM and it grabbed a new IP address from my DHCP server, that would be considered an update, and it goes all the way back to day 1. If it's the same IP address with the same computer name, that's a refresh and nothing would have happened. But in this case, I've abandoned it. The next thing we're going to look at is the refresh period. Now during this time, DNS says, okay, I'm going to wait for you to refresh. You've got something from DHCP, so when is the first DHCP lease renewal interval? 50%. By default, DHCP lease is 8 days. What's half of 8? 4. So it's going to say 4 days. So now I'm into 4 days. I still haven't renewed my DHCP lease. When's the next DHCP lease renewal interval? 87.5%. What's 87.5% of 8? 7. 7 days. That's why all these numbers are 7. Because now we have given that resource record a full DHCP lease renewal interval period of time, 4 days and 7 days, in order to renew, in order to refresh itself. Now, nothing has happened. So now we're in our scavenging period. So now the scavenging period says, okay, I'm going to, at the end of 7 days, I'm going to run the scavenging process, and I'm going to say, is the current date and time of the server less than or greater than the date of the resource record timestamp? If that record is old, it's going to say, I'm going to scavenge it. All right, that's a stale record. It can now be scavenged or deleted. But now how can you tell if the scavenging process has run, what it has done, and when scavenging will run next? You're going to look in the mythical thing called an event log. The DNS server event log, you're going to look for event IDs 2502 and 2501. 2502 tells us that it has gone out to do a scavenging cycle. And then you'll see the line that says the next scavenging cycle is scheduled to run in 168 hours, which is 7 days. And then 2501. 2501 says, hey, I've run a scavenging cycle, and here's all the stuff I processed. Now, for some reason, I had powered down my lab, and that's how I kind of figured out that the scavenging time gets reset when you kind of power off and back on DNS servers. So I never was able to get a screenshot of where it actually processed, so my friend Joe Harder sent me one from one of her customers. And this is one that shows us that it scavenged 7 nodes and scavenged 7 records. Now question, what nodes and what records were deleted? Don't know. Now in the PDF, I found an article from someone at Microsoft that walks you through how to set up auditing of deleted DNS records, but even in my little simple lab, it created so much traffic, I was like, nah. So, but anyway, there's a link in there to the PDF on how to audit DNS deletions. But now, is the record really deleted? Not exactly. Any of you ever work with Wins? Yeah? Okay. Then you know what happened. So let's go take a look at our record in ADSI edit. We're going to connect to the domain component, domain DNS zones. And so we're going to connect to it. And then what you're going to do is you're going to click on domain DNS zones, expand it, and then click on Microsoft DNS and expand it, and then click on your scavenging server. And then you'll come over here and you'll find your record, and you can see my Apple TV and my phones and iPads and everything else. We're all getting DNS records and everything. So my Win7 record is the one I created and abandoned. Now I'm going to right click on it, and you'll see it has a tombstone record set. It's now been DNS tombstoned. And where does it exist? It exists in the deleted objects container. If you ever worked with the AD recycle bin, you're familiar with the deleted objects container. Now, I don't know of anyone who can recite from memory how to get into the deleted objects container. So in the PDF, I got the long set of instructions on how to actually get into the deleted objects container so you can actually see what DNS records have actually been deleted. So now, the DNS tombstone period is also 7 days. All of these you can set. The no refresh, the scavenging period you can set in the drop down. The DNS tombstone, you have to set a registry key to change it. So now it's going to say, hey, I'm going to now wait 7 days while this thing is tombstoned to see if anything else happens to it. Because I could power on that VM and reanimate that object, that DNS record, and poop, it's right back. Now it's right back because I'm running server 2012. If you're prior to 2008 R2, there's a bug. If you reanimate with the same computer name and IP address, or a different computer name getting that IP address, screwy things are going to happen because of a bug. And what it's going to do, especially in a high traffic environment where you're getting many hundreds or thousands or tens of thousands of refreshes and updates on a daily basis in your DNS, what will happen prior to 2008 R2 is your Active Directory database will just grow and grow and grow and grow, because all of these tombstone records are never cleaned. They're never removed because of a bug. There's a hot fix. So if you're on prior to 2008 R2, there's a hot fix. This has been fixed in 2008 R2 and server 2012. What if you're running in a mixed environment? What if you've got 2003, 2008, 2008 R2, and 2012 domain controller / DNS servers? The bug would affect whichever one is the scavenging server. So if you've got a mixture and your scavenging server is 2012, you're good. If your scavenging server is 2008 R2, you're good. Prior to that, you need the hot fix. Now, the only thing that is not configurable in this entire process is at 2 a.m. every morning, there's a process that runs on that scavenging server that says, has this DNS tombstone record, has it been in there more than 7 days? If it has, it is finally removed from the bowels of Active Directory. So now how long did this entire process take? I enabled aging and scavenging, I created a record, I abandoned it, and it was 29 days before it was completely removed from Active Directory. It was on sometime between day 21 and day 22 before it was actually removed from the DNS console. Now when it deletes the record, it actually deletes it from the in-memory cache on the DNS server, and it also removes the DNS record from the DNS console by setting that flag DNS tombstoned. And then DNS knows that that record is not supposed to be loaded. So every time you reboot the server or you restart the service, it knows that I'm supposed to ignore that because the DNS tombstone has been set. And I know you're all so excited, but wait, there's more. There's a lot more. And I'll tell you what, we got 20 seconds before the break, so I'll let you go. So if you need to go to the bathroom, or so the people from that class can come over, or if you want to go over to the NetScaler class, so we'll take a 5-minute break, and then we'll come back and I'll give you the much more. See you in just a couple of minutes. As soon as Alex closes the door, we'll get started again. Okay. Now let me go back to this slide and answer a question that people ask. All right, if you were to go back to the office on Monday and get all your aging and scavenging stuff configured, how long will it take before records start being deleted from DNS? Well, if you've got a whole bunch of old stale records out there, you come in on Monday, day one, and enable aging and scavenging. The start scavenging time on the server is the current time on the server plus the refresh interval, which is going to be 7 days. So somewhere between day 7 and day 8, the scavenging process will run and start deleting all those old, stale DNS records sitting out there. Then it's going to wait the 7-day tombstone period. So now we're on day 14, 15. So somewhere around day 15 at 2 a.m., if the scavenging process and everything ran after 2 a.m., say your scavenging process, say you woke up early in the morning and got everything configured at 3 a.m. Well, it's actually going to be 2 a.m. the next day that the 2 a.m. process for deleting the stuff out of the tombstone stuff will actually run. So somewhere between days 14, 15, 16, depending upon, all the times and intervals and stuff, before all the stuff that's currently in your DNS is actually removed from Active Directory if you were to go and turn it on Monday. So that's how long it will take. So in other words, DNS aging and scavenging is not one of these things you can go in on Monday, turn it on, and come in on Tuesday and find DNS all cleaned up. Now it's going to be 7 to 8 days before you'll start seeing stuff removed from the DNS console, and then somewhere between day 14, 15, 16, at whenever the 2 a.m. interval is going to run, before the stuff is actually out of the deleted objects container and completely gone out of Active Directory. So you have to be patient with aging and scavenging. But like I said, but wait, there's more. What about DHCP? Who owns the DNS record? The client does. The client dynamically registered. The computer dynamically registered, or the server dynamically registered its static IP address. Because remember, prior to Vista Server 2008, the DHCP client service, from Vista on, 2008 on, the DNS client service actually does the dynamic registration. So the client owns those records. So in the case of my abandoned VM, that client owned that record. So who is allowed to update or refresh that client record? Only the client. No DHCP server can, no other computer can. Because the client owns the DNS record, which is not a good thing. So how does DHCP play into all this DNS stuff? Well, now we have our DHCP lease duration. By default, it's 8 days. And as we discussed earlier, the first DHCP lease renewal interval is 50% or 4 days. The second is 87.5% or 7 days. So if you use the default 8-day lease duration, your no refresh interval and your refresh interval should be greater than the first DHCP lease renewal interval and less than your DHCP lease duration. So those intervals should be set to more than 4, less than 8. In other words, 5, 6, or 7. If you leave them at the default of 7, you're allowing DHCP to go through its complete renewal process for the 4 days and the 7 days. So a question that comes up is, well, what if I lower this down to like 1 day? You're going to run into some issues. Because our no refresh and refresh have to be less than half of that, or 12 hours, but less than the 24 hours. And there's a minimum time interval you can actually set for the no refresh and the refresh, which I believe the minimum is 1 day. Now the scavenging period can be set down to as low as 1 hour. So now let's think about this. If I were to set the no refresh, the scavenging period all to like 1 day, how much DNS activity do you think will happen on your network? How many updates to that Active Directory database do you think will happen in that time period? Enormous amounts of DNS activity will happen. Enormous amounts of writes to your Active Directory database. And what happens when the Active Directory database is updated? It has to replicate all those changes to all the other domain controllers and all the other DNS servers in your environment. You will now have a flood of Active Directory replication traffic, which is not a good thing. So if you're going to re-IP your network, and you're going to need to change your DHCP lease duration down to like 1 day so that you can go through the cycle process of re-IPing your network, just turn off all the aging and scavenging stuff. Just turn it off. Because even if you go from like 192.168 IP scheme and now you're going to a 172.16 IP scheme in your environment, and you set your DHCP lease duration to 1 day, or even sometimes hours in the case of maybe a wireless network. Turn off all the aging and scavenging stuff. Once you got everything done, turn it back on, and what's going to happen? 7 to 8 days, it will go through and start cleaning all that stuff out of DNS. Now, if you've got all the aging and scavenging stuff configured properly, you can actually go in there and highlight all the old IP addresses. Just highlight them all, or maybe run PowerShell if you're on server 2012. I believe some people, some MVPs have made PowerShell wraparounds for the DNS command stuff, and you can go out there and you can manually delete all that stuff. But when you do, all you're doing is setting the DNS tombstone flag, and now it's going to sit still in Active Directory. It will not be loaded by DNS because it's DNS tombstone. Then you got the 7-day DNS tombstone period, and then somewhere after the 8th day, then that 2 a.m. process will run and then clean all that stuff out of Active Directory. Now we have DHCP option 81, which is also called the DHCP DNS options, which is also referred to by Microsoft as the DHCP client FQDN option. This is where you would set the DHCP server to control all DNS updates. By default, it doesn't. So, our DHCP DNS recommended settings, are we going to tell it that we want to always dynamically update both forward and reverse lookup zones? And we want to dynamically update all records even if the clients don't do it or don't request it. And according to the Microsoft documents, this means it will also update DNS for Unix, Linux, and Mac OS X. And in this way, DHCP controls everything. Then, Server 2008 R2 and higher now have name protection. So what is name protection? Name protection allows DHCP to prevent a non-Windows client from squatting on one of your Windows servers' names. So say we have server 1, it's a Windows server, has an IP address of 192.168.1.1. and then someone brings up a Unix server called Server 1, and DHCP assigns it 192.168.1.1. Which record is going to wind up in DNS? Last write wins. Now all of a sudden, your Windows server has been overwritten by a Unix server name in DNS. And I don't think your Windows clients that are expecting results from a Windows server are going to like that. So name protection prevents that type of squatting. Now, this is covered by, on the server side, RFC 4701, 4702, and on the client side by RFC 4362. So if you ever suffer from insomnia, you can be like me and just read all these RFCs. And they're really cool reading. But what this does is this says, hey, non-Windows clients cannot be updated in DNS if a Windows client already has the DNS record. So if I enable name protection and I've got server 1 and then someone brings up a Unix server, server 1, DHCP will say, I will give you an IP address, but I am not going to put you in DNS because I've already got a Windows client over here with that registration in DNS. So it protects the Windows name in DNS. So when you enable this, this also tells you that it's also going to handle all the DHCP option 81 stuff. So now once you enable this and you go back to the DHCP option 81 screen, you'll see that all this stuff is now grayed out because this is now being handled by name protection, which is all pretty good. But now we've got another problem. I got DHCP server 1, and it's been handling all my DNS updates for everything. It dies. No problem. I'll bring up DHCP server 2. Who owns all those DNS records? DHCP server 1. So can DHCP server 2 update them or refresh them? The SID belongs to DHCP server 1 as the owner of those DNS records. So now what are we going to do? You're going to add your DHCP server or servers to the DnsUpdateProxy global group. And you're going to add all your Microsoft DHCP servers in there. Now, there is one Microsoft article that states never put a domain controller that runs Microsoft DHCP in the DnsUpdateProxy group. There are a couple of 100,000 other Microsoft articles that say all Microsoft servers running DHCP go here. So I'll go with the 100,000 versus the one weird article. So you can put all your servers in there, and now we're good, right? It's Microsoft. Of course not. Servers that are in the DnsUpdateProxy group can only do unsecured dynamic DNS updates. By default, how are dynamic updates configured? Secured. Which means that now we can't update anything in DNS. So how do we fix that? We're going to configure credentials on our DHCP server. So if you're using secure dynamic DNS updates, which you should, and your domain controller is on the same host as your DHCP server, which in a lot of environments is, you're going to configure credentials, and these credentials can be just a regular domain user account. Doesn't require any special privileges or anything. Now, one thing I've not done, mainly because I've been speaking at conferences for the last 3 weeks, is I forgot to test this with the new Server 2012, the group managed service accounts. So I need to go and create a group managed service account and use it for multiple DHCP servers, especially with Server 2012, where you can have the failover DHCP servers and actually see how that works. So I will be testing that. So how do you configure the credentials? You're going to go to your protocol, click on it, then right-click. This is the same for IPv4, IPv6. If you do it at the protocol level, it applies to all the subnets you defined or all the scopes you defined underneath. Or you can do this for each scope if you want to. I prefer, and Microsoft recommends that you just do it at the protocol level. Then you're going to go to the properties, go to the advanced tab, click on credentials, and just enter your credentials there. Now, if you use name protection, which I would recommend that you use, you must protect the DnsUpdateProxy group. Microsoft also recommends that you do this regardless of whether you use a name protection or not, meaning prior to server 2008 R2. So you're just going to run this command, DNS command /openacl on proxy update. So Microsoft recommends that you do this always. Whew. That's a lot of stuff. And so people want to know, man, why isn't my aging and scavenging work? That's because there are about, as you can tell, about 1,000 interlocking parts to aging and scavenging. And if you affect something as simple as your DHCP lease renewal time, that flows all the way down into the aging and scavenging. So now, before questions, let me see if I can wrap all this up for you. You do want DHCP to handle all DNS updates in your environment. And you will therefore put all DHCP servers in that DnsUpdateProxy group. You will do credentials, and you will secure the DnsUpdateProxy group, and then you're going to preferably leave everything on the defaults. If you're on server 2008 R2 or 2012, you will enable name protection. If not, you will enable the DHCP option 81 stuff so that DHCP will always dynamically update the host records and the pointer records. And then in all your aging and scavenging, you're going to enable aging and scavenging, hopefully leaving everything at the defaults. You're going to set one scavenging server, so to make it simple to troubleshoot the stuff. And you're just going to preferably leave everything at all the defaults, and then once you get all that set, then you can start checking in 8 days, 15 days, 22 days, day number 29, and everything should now be cleaned up out of DNS. All that old DNS stuff will be cleaned up out of DNS and also cleaned up out of the bowels of Active Directory. And that's all there is to aging and scavenging. Questions on this entire process? That's a lot to digest. Now you know why I didn't go through all that last year. It would have been a 3-hour session last year. All right, then let's go on to the second most asked question. All right, we're going to talk about single domain, single site, just a refresher on what we covered last year. And then we'll go through single domain, multiple sites, multiple domain, multiple sites, and then we'll put it all together. Now, as a reference point, Active Directory is complex. Active Directory has a lot of pieces and parts. But you can boil Active Directory down to 2 simple guidelines. Active Directory prefers that you keep everything as simple as possible, which was why last year's recommendations, Microsoft's recommendations for Active Directory: 1 forest, 1 domain, use OUs for management, and then your sites for replication. And that will go for, even according to Brian Desmond, the super genius of directory services, he has rarely seen even multinational corporations that need anything more than that. And you need to have a good reason to go beyond the 1 forest, 1 domain, sites, and OUs. Now beyond that, you can make Active Directory as complex for your job security as you require. But the one thing that is most important to Active Directory is consistency. Active Directory really doesn't care what you do, as long as you are consistent in what you do. And that's one of the problems I find when I go out and do Active Directory assessments, is that there's no consistency to stuff. And so what we're going to do, what I'm going to show you, these are just guidelines, recommendations. These are not rules. These are not hard and fast. These are not, you're stupid if you're not doing it this way. Now, these are just guidelines. And these come from some of the smartest directory services, because I've run this by several directory services experts and MVPs. Simplicity, consistency. So, refreshing from last year, where we had our single domain with a single site. What we did is we picked one domain controller to be our primary DNS server. I prefer the domain controller that holds the PDC emulator FSMO row, because to me, the PDC emulator FSMO row holder is the most important domain controller in your environment. In Active Directory, all domain controllers are equal. The PDC emulator is the most equal of them all, because when someone changes their password, it goes there. When someone's account gets locked out, it goes there. When someone fat fingers their password, and they can be in another site far away, if they fat finger their password, the authenticating domain controller must come all the way over to the PDC emulator to say, did the user change their password and I haven't been informed of it? No? Okay, they fat fingered the password, I'll give them the invalid logon prompt. And then in Server 2012, if you're going to use the new, in Hyper-V, the new domain controller cloning thing, you must have the PDC emulator online. And so then we're going to pick another domain controller to be our secondary DNS. And so in this simple environment, what we've decided to do is that all servers, including the primary, points to the primary for primary DNS. All servers, including the secondary, point to the secondary DNS for secondary, and then they all use their local loopback address for tertiary. And then if you run the Directory Services Best Practices Analyzer in this environment, and you have it configured this way, you will get a clean bill of health. If you don't, the Best Practices Analyzer will tell you that you got it configured incorrectly. Especially, you have two teams at Microsoft that don't talk to each other. The team that wrote DC Promo does not talk to the team that wrote the Best Practices Analyzer, because I can have a domain controller set with a static IP. What happens when I run DC Promo? What does its primary DNS address become? 127.0.0.1. Best Practices Analyzer says, no, that should be the tertiary DNS address. So then stuff I'm giving you today will help you get a clean bill of health from the Directory Services Best Practices Analyzer, because if your boss wants you to run that report and give it to him, would you rather do it your way or a way that gives the clean bill of health and you can give him a clean report and he says you're doing a good job? What if I've got a single domain with multiple sites? In this case, each domain controller points to itself for primary DNS. It will point to another domain controller in this central site for secondary, and then they'll all point to themselves for tertiary. And then now, what if we've got a remote site with a single DC? And that remote site, it's going to point to itself for primary DNS, and then we'll come back and point to a domain controller in the central site for secondary. In this case, I've got it pointing to the PDC emulator because it made the drawing look cleaner than going to any of the other two. And then it will point to the local loopback for tertiary. Now, the problem that I see is that people will set this up, and then this domain controller goes out of maintenance, or the WAN connection is not exactly that reliable, or they got issues, or they cut down on IT staff, And so now they don't have anyone to maintain this, so they just send someone out there. He pulls the power cord out of the domain controller, yanks it out, they bring it back to the central site, and they reformat it and use it as some other server. So now we have three things wrong. We have three abandoned entities. We have an abandoned or orphaned domain controller in Active Directory because the domain controller was not DC promo down. We now have a site that has been abandoned and is still in Active Directory. And we now have a subnet or multiple subnets that are now abandoned in sites and services. So now that's going to drive the knowledge consistency checker, or KCC, up the wall. That's going to drive replication up the wall. And now all of a sudden, if you now take that subnet and it goes someplace else, you now bring, say that remote site DC4, say it had the 10.4 subnet was assigned to that site. That site's now abandoned, but it still exists in sites and services. You now take someplace else, you now bought the 4th floor in your building, and now that's now 10.4. When those computers come up, what domain controller are they going to try and hit? That one that doesn't exist anymore. Because you have told KCC that anything that has 10.4 needs to go to that site to hit that domain controller, because that site is responsible for 10.4. And then after timeout period, it's going to realize that that's not there. You're going to get all kinds of errors in your event log saying that I can't replicate, group policy, DNS, nothing's working. So we're going to send the client somewhere over here. You need to fix the issue. And of course, no one ever looks in the event logs. And they don't ever see this until they hire someone like me to come in. And then we have to get all the stories behind, oh, that happened a year and a half ago. Oh, is that why we're having so many logon problems? Is that why we're having so many replication problems? Now, if we have a remote site that has multiple domain controllers, in the remote site, each domain controller will point to itself for primary. Then they will point in the site to another domain controller in the site for secondary. And then, depending upon the speed, congestion, reliability of the connection, they can come all the way back to the central site and point to any other domain controller in the central site for tertiary, or they can use the local loopback for tertiary. And that's just one recommendation. And then when you have remote sites, it is very important that you remember that when you remove a domain controller or you re-IP your network, that you need to go in and clean up sites and services. Because if you don't, then KCC goes crazy, replication goes crazy, and if you try to run DC diag in an environment where you, like the previous slide, where we had a remote site and we removed it and we removed the domain controller, DC diag will take hours to run because it tries to read each group policy off that domain controller, and it can't, and it will time out on every group policy. It will time out on every test. So DC diag can take hours to run. All right, now, what if we have multiple domains with multiple sites? Now for here, I'm assuming that this domain A is our root forest domain, and our domain B over here is a child domain. And the reason for that is, who's our authoritative time server for the forest? The PDC emulator in the root forest domain. What is the only computer in the entire Active Directory forest that should be configured for time? The only one. The root forest PDC emulator, which in this case I'm going to assume is DCA-1A. That's the only computer that should be configured for time. All the other computers will use the time hierarchy, which means that these domain controllers will come over here for time. In this domain, they will go to the PDC emulator here for time for this domain, and then other workstations for domain B will come to these domain controllers. Other workstations in domain A will come here for time. This PDC emulator for domain B is the only one that may or will eventually ever come up over here to the PDC emulator in domain A in case if it can't get accurate time. But I've got a reference that explains how all this time hierarchy works, but the important thing you should realize is that you can have hundreds of thousands of computers, tens of thousands of servers, or you can even have thousands of domain controllers. Only one computer in your entire network should be configured for time. This one, nothing else. So now for our DNS configurations, in each domain controller is going to point to itself for primary, to another domain controller in its domain for secondary, and another domain controller in the domain for tertiary. We're not using local loopback. And then for the multiple domain, we are just going to use secondary zones. We're not using forwarders. Forwarders have to be configured on every single domain controller. Secondary zones do not. All right, and here we go. We've added our first remote site. And then the concept is essentially the same in each domain. Each domain controller will point to itself for primary, another domain controller in its domain for secondary, and then going back into the central site for tertiary within their domain. You don't ever cross, because remember, for name resolution and stuff, we're using secondary zones. And then the same thing over here, these domain controllers will look to themselves for time. Other computers at this site will come to these two domain controllers for time. Now there's actually a mathematical model to all of this that Microsoft has. The PDC root emulator gets a score of 8, and then because it's in its same site, that gets it another 1. So it has a score of 9, which means it is the most authoritative time server in the environment. It has the highest number, and then each of these have different scores. And then that's how you can determine the time hierarchy in your environment, and all of that is covered in the PDF. And then when we add another site, whether it be site 3 all the way up to however many sites they have, this is basically the same concept. Each domain controller points to itself for primary, another domain controller within its domain for secondary, and then we're going to come back into the central site and just point to another domain controller somewhere in the central site within its domain for tertiary. And then that just expands and expands and expands. And then you must always take into account that your sites must be defined in sites and services, that you have the appropriate subnets defined, because the last thing you want is for someone over here to be going all the way into site 3 for its authenticating domain controller. And that does happen, because sites and services doesn't have all the proper subnets. So if I'm a client over here, and all of a sudden you've added new IP addresses, if for some reason these are busy at the time for some reason, and I bring up my computer and I go to DNS and say, hey, I'm IP address 10.6.1.2, and it says, oh, I don't show anything for 10.6. Let me go and check, and no, I don't have anything in DNS for that. So it then just says, okay, here is the IP addresses of every domain controller in your domain. And then the client then throws that out and says, I need an authenticating domain controller. And then all of a sudden, DCA-3B says, I'm available. Now all of a sudden, you're going way across, maybe the world, to authenticate. And that's now where all the login scripts, group policies, batch files, everything is going to come all the way across that WAN over here all because you didn't define a simple subnet in sites and services. Okay. I get to do a lot of AD work. I spend a lot of my time doing AD work. And the most complex environment I've ever been asked to do an assessment on was a new company coming in. They were going to do everything Server 2012. All brand new, starting from scratch. But they had 8 sites. No problem. Except they wanted each site to be its own domain. Now, all these 8 sites are in one geographical area. They're in one metro area. And they wanted each of them to be their own domain. And they wanted 2 domain controllers from each domain in each site. In case you can't do the math, that's 128 domain controllers. And each site was connected back. There was basically a hub and spoke, a main data center, and then they had the 7 sites. All of them were connected via redundant 300 meg fiber. And I told them that was ludicrous. They didn't need 8 domains. They actually didn't even need 8 sites. I mean, yeah, granted they were 8 physical locations, but they weren't using anything. They weren't going to use DFS or any other piece of software that required sites. And so I told them that all they needed, because they were so well connected, and it was a full mesh, almost a full mesh scenario in this case, which I'm assuming was very expensive for redundant 300 meg pipes. All they needed was 1 domain, 1 site. That's all they needed, 1 site. And then just let KCC handle all the replication. Use OUs. You could have an OU for each of the 8 sites, so they could do whatever management. And they scoffed at me. So I tried, like I did the others, I drew it up for you in all my color blindness. I came up with the drawing for you, and this is what their network basically looked like. And do any of y'all follow Shane Tech, Mark Naus on Twitter? Well, he came up with a really good tweet about 3 weeks ago that said the #1 job of an IT architect is not to do complex architecture just for the sake of having a complex architecture or for your ego. And 128 domain controllers? Can you imagine the change management control? The Windows updates? The replication traffic? Trying to keep up with how everything's connected in sites and services? That is just absolutely crazy in my opinion. And I told them, they hired me for 120 hours. I think I spent 10 hours. And then I was not asked to come back because I thought their stuff was stupid. But I told them that they needed to contact Microsoft Consulting or Microsoft Professional Services, because I knew that Microsoft Consulting would say the exact same thing. Now that we have our multiple sites, now what? Well, we're going to create sites. How many sites should I have? The usual answer: as few as possible and as many as you need. No more, no less. But you need to make sure you have all your sites defined and created in sites and services. It's amazing how many people don't do this. They've got sites, but they never create them in sites and services. Because the network infrastructure team, the firewall team, the router team, the switching team, all those people, the web content filtering, they know all about all the stuff that's going on, and no one ever tells the AD team. And now we're going to create subnets to match to the sites. So when you create your subnet, it's going to ask you, well, what site covers this? Now, there's another thing you can do that you can do. It doesn't work for all enterprises, but you can create a catch-all subnet and match it to a site. You want to be as specific as possible, but you can create catch-all subnets. So I could say, hey, anything that starts with 10 dot say goes to the central site. 172.16 goes to site 2, 192.168 goes to site 3. Then that way, if at the central site they buy the 4th floor of the building and they go in and put in all these computers and everything and never tell you about it, and they assigned it 10.4, where are they going to go? They're going to go exactly where they need to go. They're going to go to the central site because it starts with 10. And then, of course, being the good admins that you are, you're going to look in the C Windows debug netlogon.log file. You're going to go all the way down to the bottom, and then all of a sudden you're going to see, oh, I've got all these 10.4 computers trying to authenticate to my domain controllers. And then you'll go in and add a specific subnet, 10.4, to catch that. Now, this doesn't work in all enterprises because of, all the weird IP schemes and stuff. And then you're going to create site links. As smart as KCC is, and as smart as Active Directory is, it knows absolutely nothing about your LAN or WAN topology. You have to create. So in this instance, I created a central site to site 2, central site to site 3, and site 2 to site 3. And you'll, also notice that site 2 to site 3 has a cost of 500. And what that means is I can always go from site 2 to the central site to site 3. But what happens if something happens to my link from site 2 to the central site? What if that gets cut or something happens to it? I can still get to site 3 from site 2 by going here, but KCC knows that that is a last ditch effort because of how expensive that site link is. And then you're going to place your servers in your sites, and then in Server 2012, when you're running the domain controller promotion process, you can now actually specify the site during the DC promo process. And now we're going to let the KCC and Active Directory do their job, and we're going to stay out of their way. How? Glad you asked. We're going to check our domain and force functional levels because we're going to get away from all those 2000, 2003 force functional levels. We're going to get to 2008, R2, and 2012 so that we can have more efficient KCC generated replication topology. We can use link value replication for our security groups, and then also use things like AD recycle bin, and in 2012 have a GUI for the recycle bin and fine-grained password policies. All domain controllers should be global catalog servers, even in a multiple domain environment. Because when you do that, the infrastructure master has absolutely nothing to do, and you don't have to worry about all those weird, well, if you have this role can't be on a global catalog server. None of that applies if all domain controllers are global catalog servers. No manually created connection objects and sites and services. If you find you're having to create a manually created connection object, you have not given sites and services enough information about your sites, your subnets, or your site links. And then you're going to check the netlogon.log file for missing subnets. And then you're going to add those missing subnets into sites and services. And then once you have those subnets defined, you're going to create reverse DNS lookup entries for all those subnets. Now, Active Directory itself could care less about reverse DNS. Active Directory will go on forever and ever with never a reverse DNS lookup zone created. But if you're using XenApp or Web Interface or XenDesktop or View or vCenter or any number of other virtualization products, they will either require or will work best if you have a reverse DNS lookup zone created. And then what we covered in the first half, you're going to make sure you're using all the aging and scavenging stuff to clean up DNS of unnecessary duplicate host names and IP addresses. And then you're going to clean up orphaned domain controllers, which if you're on 2008 or higher is real easy. You find it in ADUC, you right click, you select delete, and it will automatically do the metadata cleanup for you. If you don't have the RSAT tools installed or you don't have a 2008 domain controller, you've got a lot of work ahead of you. You're going to make sure the PDC emulator is configured properly, and that is the root forest PDC emulator. Then you're going to make sure all domain controllers have their DNS IP settings configured properly. And then you're going to use Microsoft and all the other vendors' Active Directory design guidelines. Questions? All right. If I got my time zone conversion right, you should be able now to get the PDF of this presentation, all the slides, all the notes, all my research, and then the hidden slide with the 90 some odd reference articles on there. Thank you very much for coming.